Here's a look at problems 6, 7, and 8 on the horizontal review. A person slides off a sliding board into a pool as pictured below, or as I drew here. They leave the sliding board with a velocity of 6.3 meters per second. That's going to be horizontal. They land 5 meters away from the end of the slide. How high is the slide above the water? We're looking for D in the Y direction. So we're going to write our numbers into our X and Y columns. Displacement in the X direction was given at 5 meters. The velocity in the X direction, 6.3 meters per second. In the Y direction, we are looking for how high the slide is. So we're looking for how far he falls because it's the same thing. So displacement in the Y direction is our question mark. Initial speed is 0 because he's being launched horizontally. And the acceleration is negative 9.8 meters per second squared. We only have two numbers in the Y direction, so we can't solve for the displacement yet. But if we solve for time in the X direction, we can get time in the Y direction. So that's what we're going to do. Displacement equals velocity multiplied by time for constant velocity motion, which the horizontal always is. Time is displacement over velocity, so 5 over 6.3, and that's going to give me a time in the air of 0.79 seconds. We can use that in the Y direction now. Pick the equation that does not have VF in it. That's right here, D equals V naught T plus 1/2 AT squared. V naught is 0, so our equation just becomes D equals 1/2 AT squared. So plugging in my numbers, D equals 1/2 times negative 9.8 meters per second squared times 0.79 seconds, square that number, and I should get a displacement that should be negative 3.06 meters for the displacement of the person, but the question was asking how high is the slide above the water, so 3.06 meters as a positive is an acceptable answer. Number 7. An eagle is flying horizontally at 6 meters per second. It has a fish in its claws. It accidentally drops the fish. A, how much time passes before the fish hits the ground 40 meters below, so I know my Y displacement. B, what are the horizontal and vertical components of the fish's velocity, so the X and Y velocity, when the fish strikes the ground. Now I know the fish is moving 6 meters per second to the side when it's let go, so I have my velocity in the X direction. The 40 is a displacement in the Y direction, and it's downward, so negative 40 meters in the Y. V naught is 0 because it was launched horizontally, and the acceleration is negative 9.8 meters per second squared. We're looking for the time, and we're looking for the final velocity. We can solve everything here in the Y direction. So A, solving for time, I want to pick the equation that does not have VF in it. It's the third equation again. V naught is 0, so this term V naught T cancels, leaving us with D equals 1/2 AT squared. Solving for T, I move the 1/2 over, that gets me 2D, divide by A, that's why it's in the denominator, and to get rid of the squared, I take the square root. I plug in all of my numbers, 2 times negative 40 meters divided by negative 9.8 meters per second squared, and that gives me 2.86 seconds. That's how long the fish will take to get to the ground. Now I'm going to solve for how fast the fish is going in the X and Y directions. And the X never changes. It's going to be 6 meters per second. Doesn't matter if it's falling 40 meters or 140 meters. The X velocity never ever changes. So when it gets to the ground, X velocity is 6 meters per second. The Y, however, we have to find. Using the last equation, one without T in it, I found that VF equals the square root of V naught squared plus 2AD. Plugging in my numbers, V naught is 0, so it just goes away. Square root of 2 times negative 9.8 meters per second squared times negative 40 gets me 28 when you plug it into your calculator, but remember, coming out of the square root, it can be positive 28 or negative 28, and it's moving downward, so it's negative 28 meters per second. Number 8. While vacationing in Mexico, you come to a cliff overlooking a river. Thinking it would be fun, you run toward the edge of the cliff and jump off with a horizontal velocity of 5.5 meters per second. You land in the water 1.6 seconds later. How high is the cliff? So I want to know the displacement in the Y direction. And how far from the base of the cliff do you land? I want the displacement in the X direction. So I'm looking for both D's, X and Y. Plugging in my numbers, I know my X velocity is 5.5 meters per second. The problem told me that it takes 1.6 seconds to get to the water. In the Y direction, initial velocity is 0, acceleration negative 9.8 meters per second squared, and time, as is again given in the problem, 1.6 seconds. Doesn't matter which one you solve for first here. I guess I'll do the X first. It's constant velocity, so displacement equals velocity multiplied by time. Velocity was given, time was given, multiply them together, and I know you land 8.8 meters away from the cliff in the Y direction. Again, V naught is 0, so the V naught T term cancels, leaving me with D equals 1/2 AT squared. I plug in my numbers, multiply everything together, don't forget to square the 1.6, and I get negative 12.54 meters. So the cliff is 12.54 meters high, or you fall 12.454 meters.